Hello. So today we're going to be doing multiplying a polynomial by a polynomial. So on Monday you just did a monomial, one term, by a polynomial, multi-terms. So this one has some similarities, but it also has a little bit more in terms of distributing. So when you do this, I'm going to show you two ways. You can either use what I call super distributing, because there's a lot of it, or the box method. I'm just going to tell you right now, I prefer the box method because when I multiply, it helps me keep track of everything. But it is up to you as to which one makes the most sense. So on number one, we're multiplying a binomial times a binomial. There's two terms in the first set of parentheses and two terms in the second. So what we need to do first, I'm going to show you the super distributing, is we're first going to take 2x and we are going to multiply it by everything in the other parentheses. This is the beginning of our distributing. So we're going to go 2x times 3x to get 6x squared. Don't forget your exponent rules. And 2x times negative 5 to get a negative 10x. But then I still have another term in my first parentheses. I have this plus 3. So now I'm going to multiply everything in the second parentheses by a positive 3. So 3 times 3x gets me 9x, and 3 times negative 5 is negative 15. If I then look at this as four terms, I have two of them that are like terms, these middle ones. So the 6x squared is the only x squared term. The negative 10x plus 9x simplifies to negative 1x, and we still have a minus 15. So that's the super distributing method. If you have an older brother or sister, or maybe your parents have done some of this math recently, you'll hear them call it FOIL. FOIL stands for first, so that means we multiplied the first terms in both of them. Then outer, which means we multiplied the ones on the outside together, which is what we did. And then I stands for inner, which means we multiplied the ones on the inside together. And then L is last. The last terms in each binomial were then multiplied together. FOIL is just super distributing. It's the same stuff. Now here's the other method that you can do, and it's the box method. And I'm going to show you this because when we start doing factoring, you will be using a box. Now let's just say that we had just started this problem, and I would be multiplying 2x plus 3 by 3x minus 5. In my box, what I can do is I'm going to write the first binomial, 2x and a plus 3, on the top of the box, and 3x minus 5 on the bottom of on the side of the box. And if you'll notice, each part of the box has one term. So what you do to figure out the answer to a box is you multiply what's on the above it and to the side of it. So for that box that I've highlighted, we'd multiply 3x by 2x to get 6x squared. To find the next box, I'm going to multiply my 3 by a 3x, and I'm going to get 9x. To get the bottom left, I'm going to multiply 2x by negative 5 to get negative 10x, and the bottom right, 3 times negative 5 to get negative 15. But if you look at what's inside the box, it is exactly the same as that, as our super distributing. When you want an answer from the box, you just combine like terms. So in the box, the 6x squared is the only x squared term. Your 9x and negative 10x are like terms, so those can be added. And your minus 15 is its only term, only constant, so you end up with the exact same answer. So it is fine whatever method you want to choose. I'm going to tell you right now that when we get into factoring, you will see the box, so it's not going to go away. But if you prefer to do super distributing, also known as FOIL, that's totally fine. So let's try another one. So we have, and I'm going to go back and forth as to what exactly I do on these ones, just to kind of give you an idea. So if I'm going to multiply these two binomials, I'm first going to do this with, this one's going to go with the box method. And I'm going to multiply an x minus 9. See, each term is in each column. And then 4x minus 3. Each term is in each separate row. So for the upper left-hand box, I'm going to multiply x by 4x, and I'm going to get 4x squared. For the upper right, I'm multiplying what's above it and what's to the left of it, so negative 9 times 4x is negative 36x. In the bottom left-hand corner, x times negative 3 is negative 3x, and in the bottom right-hand corner, negative 9 times negative 3 is a positive 27. So my answer is, I have a 4x squared, it's the only x squared. I have two terms that are alike, these two right there. So negative 36x minus 3x is negative 39x, and then plus 27 is the only constant. Okay, let's try super distributing for the next one. Now on this one right here, if you're going to square something, you cannot use your exponent rules because there's this minus sign right there. Every time we use the power to a power, it looked something more like 5xy squared cubed, and we are able to distribute. But if you'll notice in this problem, there's no plus or minus signs. It's only one single term. You cannot use that rule when you have a binomial. So another thing that squaring means is to multiply by itself. So what this problem is really saying is 5x minus 1 times 5x minus 1. So if you see a problem where it's a binomial squared, you need to write it out as it's being multiplied by itself. So if I used FOIL, or super distributing on this one, 5x times 5x is 25x squared. 5x times negative 1 is negative 5x. So I've multiplied everything by 5x. Now I'm going to take the negative 1 and multiply everything in the other parentheses by it. Negative 1 times 5x is a negative 5x, and negative 1 times negative 1 is a positive 1. Now combining like terms, this is the only x squared term. I can combine my x's to get a negative 10x, and we have a plus 1. Okay, two more problems. So this problem, I'm going to, for this one, actually I'm going to do your super distributing on this one because the next problem I want actually to do the box method, and I'll show you why the box method is best on the next one. So the first terms are 8x times 8x, which is 64x squared. Outer, the two outsides, is a negative 24x. The inside ones are 3 times 8x, which is a plus 24x. And the last terms on each side is a negative 9. Now, if you look at this problem, you'll notice that the inside terms, the x terms, add to 0. These mean that these are gone. This is only a 64x squared minus 9. Now, I'd like you to look at the way the problem is written. There is a specific reason, and we will be coming to it later when we factor as to why the middle terms are gone based on what the problem looks like. Okay, so you're going to come across a couple of those on your assignment. Okay, last, we aren't only going to be multiplying binomials times binomials. This one's a binomial times a trinomial. So the way I'm going to write this one is in my box, I'm going to do a 2 by 3 box because it's 2 terms by 3 terms. It's a binomial times a trinomial. So my box can get a little bit different size. You could multiply a trinomial by a trinomial and just make a 3 by 3 box. But doing the box makes it so you don't lose any of your pieces. So if you're multiplying a binomial times a trinomial, please use the box so that you do not lose anything. So I'm going to put the binomial x plus 1 on the rows, and I'm going to label the columns with the trinomial because there's 3 of them, x squared minus 3x plus 4. By the way, if for some reason you had decided to do the box the other direction and had made it that way, you could also put the x plus 1 on the top and the x squared minus 3x plus 4 on the sides. You get the same answer. It doesn't matter which sides you choose for the binomials or trinomials, it all works. So if I start multiplying, upper left, x times x squared is x cubed. Middle top, x times negative 3x is negative 3x squared. Upper right, x times 4x is 4x. Bottom left, 1 times all those things are just going to be themselves because I'm just multiplying by 1 on those. Now if we look for like terms, the x cubed, there's only 1, there it is. These are both x squareds. This is going to be one of those nice things about the box. A lot of times in the diagonals, the like terms are together. So you don't lose any of your like terms either. So negative 3x squared plus x squared is a negative 2x squared. 4x's minus 3x's gets you 1x, and we have the constant plus 4. So that is multiplying that binomial times the trinomial. Okay, so today's word of the day is box, because I feel like for most people, I would say 97.5% of the world, using a box method will help them keep track of all of their numbers and all of their work. So I would really highly suggest that you use the box method. If you really want to use the other method for some of them, have at it. That's totally fine. That's just my preference. So, and what I suggest. Your assignment is multiplying a polynomial by a polynomial part 1. This is going to be one day of it. We will do it a few days, 2 days exactly. I want to make sure that you understand how to multiply them together. And your assignment for today is due on Wednesday, April 1st. Email me or write a note on Google Classroom if you have any questions. Have a great day.